Every day, you grip and turn a metal knob, assuming that this simple physical act is what directly asserts control and secures your space. But in many cases, that interaction is pure architectural theater. A surprising number of knobs have absolutely no internal mechanism at all. If you look closely at these French doors, you'll see dummy knobs. They are pieces of bronze bolted flat against the wood. There is no latch. They exist entirely to trick the human eye into perceiving visual balance. Even on a functioning door, the object you actually hold in your hand is functionally secondary. The knob itself does not open the door. As this cutaway shows, the real work is done by the spindle. This internal metal shaft running horizontally through the door is what actually transfers your rotational force to pull back the latch. When the handle is essentially a decorative attachment, it becomes clear that the interface we touch is often entirely separate from the mechanical system that actually manages our boundaries. Curious tone. Move deeper into the house, and the mechanics get even stranger. The privacy locks on your bedroom and bathroom doors provide zero actual security. They are intentionally designed with a built-in vulnerability. The exterior side features an emergency release hole, meaning anyone armed with a generic pin or a paperclip can bypass the lock in a matter of seconds. Even on exterior doors, we are easily fooled. We hear the familiar click of a door shutting behind us and assume the barrier is solid. This diagram shows the main latch bolt, and the smaller piece resting against it is the dead latch plunger. If you close your door and hear two distinct clicks, your hardware is suffering from a mechanical misalignment. When properly aligned, the dead latch rests flat on the edge of the door frame, locking the main latch in place. But if that plunger extends fully into the hole, a flat piece of plastic slides right in and depresses both latches without any resistance. This brings us to the hole in the door frame itself, the strike plate. The strike plate serves as a structural anchor. It is specifically engineered to distribute impact force, preventing the wooden doorframe from splintering during a physical breach. Standard residential safety is an illusion. It is maintained not by brute strength, but by the precise millimeter-perfect alignment of tiny, hidden mechanical parts. That mechanical precision is entirely dictated by the zero-sum conflict between human vulnerability and security. It is the reason why, in commercial and modern spaces, the round knob has been almost entirely replaced by the lever handle. This shift is driven by a core ADA compliance rule. An interior door must be operable with a closed fist, and it must require less than 5 pounds of downward force to open. But designing hardware to accommodate physical vulnerabilities, like arthritis or limited grip strength, inherently compromises structural security. Because levers are engineered to be effortless to push down, they become a high security risk on exterior residential doors. They can be easily operated by intruders, small children, and even household pets. Sometimes, hardware engineers give up on security entirely. Millions of door handles are built specifically so they can never lock. These are called passage knobs. They use latches purely to dictate architectural flow and maintain climate control between rooms, not to establish a secure boundary. Contrast that with the communicating door. In this schematic of two adjoining hotel rooms, you see a single shared door outfitted with locking mechanisms on both sides simultaneously. The communicating knob acts as a mechanical enforcer of social boundaries. To cross that threshold requires mutual, synchronized consent from both parties. Hardware design forces a compromise. Making a space easier for us to navigate inherently makes it easier for everyone else to navigate too. The physical mechanics are only part of the experience. The material finish provides a psychological cue, shifting how we approach the entrance to a room. Grasping the heavy, weathered mass of a solid brass knob conditions you. The dense material and the integrated keyhole signal that you are preparing to face the harsh realities and physical threats of the exterior world. Now look at the intricate facets of a glass crystal knob. The fragile material forces you to adopt a delicate, respectful physical touch right before you enter an intimate interior space. Every time you walk between rooms, you activate hidden kinetic energy. You trigger the swift, aggressive retraction of a metal latch. You rely on tiny brass pins dropping perfectly into alignment inside a lock cylinder, a mechanical sequence refined over centuries of engineering, followed by the tactile release of the handle as the physical barrier smoothly swings open into a new space. A doorknob is a highly calibrated mechanical compromise. It is a continuous, daily negotiation between who we want to let in, who we want to keep out, and our own physical vulnerabilities.